So, dynamic equilibrium is that state when the amount of reactants and products remains constant, or it's reached when the rate of the forward reaction equals the rate of the reverse reaction. Easy enough, but when reactions reach equilibrium, no more reactants or products are formed. We tend to want to shift this equilibrium so that the forward reaction is favoured, and maybe even in scenarios when the reverse reaction is favoured. In 1885, the French chemist Henri Le Chatelier discovered this underlying pattern in these equilibrium shifts. The equilibrium always shifts in the direction which counteracts the change that upset it in the first place. The equilibrium gets upset. For example, the copper equilibrium is like so. Hydrated copper ions have a nice autumn blue sky color to them. If we saturate this sample with a source of chloride ions, let's say sodium chloride, the blue mixture turns to this nice green color, indicating the production of this tetrachloride copper 2 ion and water. Chloride ions and water have no color, so do not influence the overall color. But when this reaction reaches equilibrium, we know that there is a certain concentration of this and this, as well as a certain concentration of this and this, reverting back and forth between reactants and products at the atomic level. Le Chatelier states that changing conditions can shift the equilibrium by counteracting the disturbance. So, increasing the concentration of one of the reactants, like chloride for example, will shift the equilibrium in the right or forward direction to use up that added reactant, producing more product, which is evident because of the green color caused by the tetrachloride copper 2 ion. Increasing the concentration of one of the products, for example water, shifts the equilibrium in the reverse direction to use up some of that added water, so the mixture now looks more blue and less green. Another way to think about it is when you consider that these equilibrium reactions get upset when you mess with their conditions. As stated before, when more reactant is added after equilibrium is reached, it's like,
hey, I can only take so much, so I'm going to process this so there's not too much chloride hanging around.
So the color becomes more green. Same thing with the concentration of products. If too much water is added, it's like,
hold up, bruh. I'm all good with the products. I'm just going to move this to the reactant side so there's less heat.
So the equilibrium shifts in the reverse direction.